A join in SQL is an operation that combines rows from two or more tables based on a related column. You do this to retrieve data that spans multiple tables, trying to find data that's relevant to one another. So here's the data I'm going to be joining. We call the country table the parent table and the person table the child table, because the person table has a foreign key to the country ID in the country table. So the first join is an inner join. So an inner join only includes rows with matching values in both tables. So if there's no matching row in either table, it's going to be excluded. So in this example, you can see the person and the country table, and I'm going to return the person ID, the name, and the country ID. And when you do your inner join here, you can see rows without a match in either table are excluded. So Alice is excluded. This is because in the person table, Alice doesn't have a country ID associated with her, and everyone else does, so she doesn't show up here. So a left join includes all rows from the left table and matched rows from the right tables. Rows in the left table without a match in the right table will have nulls for the columns from the right table. So when you see your left join here, you can see the rows in the left table without a match in the right table will have nulls for the columns from the right table. So Alice is included with a null from the record from the country table, because she doesn't have a country associated with her, so you get her back. Now a right join is the opposite of a left join, so it includes all rows from the right table and matched rows from the left table, but rows in the right table without a match in the left table will have nulls from the columns on the left table. So when you look at the data here, you can see a null person ID, a null name, but the country ID of Ireland, because rows in the right table without a match in the left table have nulls in the columns, and Ireland is included, but since there's no person from Ireland, the columns from that table are included in the results, but they're null. Now a full join includes all rows from both tables. Here you can see everything. Ireland, with the country ID of 4, has no matching country ID in the person table, so the person ID, the name, and the person country ID columns are all null. So Alice, who has a person ID of 3, has a country ID as null in the person table, so the country ID and the country name columns are null. Finally, a cross join. A cross join is absolute madness. A cross join returns the Cartesian product of the two tables, meaning it pairs each row from the first table with every row from the second table. It's useful, and I put that in quotations, if you want all combinations of data. Now the reason I put useful in quotations is because cross joins are very expensive and very dangerous. Now I'm joking a little bit, flaming the cross join. It's just that personally I've never really had much use for it, because generally when I'm writing SQL, what I'm trying to do is reduce entropy. I'm trying to filter down the data into something more manageable for the customer. Now I'm not saying there's not a use for this, there definitely is, but it's just something that you should be careful of, because a query using a cross join can have a very negative performance impact. So a few tips on using joins. If you want to use them effectively, I'd advise on using aliases. You can see me using them here as well. They make reading your SQL easier, and especially when you're joining multiple tables together. Another thing, particularly in Postgres, is try to always index your foreign keys. Now Postgres doesn't index foreign keys by default. I think some other databases do. So if you're joining on a foreign key in Postgres, give it an index. So why do you want to know the difference between all these joins? Now you might think the reason you want to know the difference between all these joins is because you want to write good SQL, but really the real reason why you want to know the difference between these joins is because you're going to get asked them in an interview. Anytime you put down database or SQL in an interview, you're going to get asked the difference between all these join types. At least the left or the right join. Oh, interviews love that. They love asking a difference between left and right join. But now you know. Now you know. Because the harsh reality is, if you don't get that job, nobody cares how performant your SQL is. Because it's not going to matter.